Hi, I'm going to go through how to do the answers to 13.1. You'll have to bear with me because I've left everything at work, so my calculator and stuff, but it should be okay, we should be good. So if we look at question 1, we can see that we've got a battery. Now EMF, I won't worry too much about that because James is going to teach you chapter 12 and talk about EMF, but we're just going to say that this battery here has got 6 volts, okay? It's got a bulb in parallel with it, and that bulb is 6 volts and 6 watts. We know it would be 6 volts anyway because it's in parallel, so it's going to get all the potential difference from this. There's nothing to share it with. This one will also be 6 volts because again there's only one bulb in this part of the circuit, and it's a 24 watt bulb. So different power. So we need to remember that power equals current times voltage, which is from the GCSE specification. Okay, and now it wants to calculate the current through each light bulb. So if we go to A, we know the voltage and power, so we can use this equation to find the current. So current is power divided by volts. So for the first one, so number 1, we're going to have 6 divided by 6, which gives us 1 amp. Okay. For number 2, here, we've got 24 divided by 6, which gives us 4 amps. Okay. Then it says calculate the current from the battery. Well, this is a parallel circuit. So if this branch has got 1 amp and this branch has got 4 amps, when they join together at this point here, our total is going to be 1 plus 4, which is 5 amps. Then part C, it wants us to calculate the power supplied by the battery. So P equals IV. So the current is 5 and the voltage is 6, okay? Which is 0.2. So give yourself a mark for that. That's question 2. Number 3, sorry. So we're going to, 3A is sketch the circuit. So we've got a 6 volt battery. Of negligible internal resistance again, so don't worry about that. It's connected in series with an ammeter. A 20 ohm resistor. And an unknown resistor R. Okay, so there's a circuit for 1 mark. B. The ammeter reads 0.20 amps. Now it's a series circuit, so all the current is that. And it would like us to calculate the potential difference across the 20 ohm resistor. So we need to use Ohm's law from GCSE, which is V equals IR. Okay. The current is the same all the way around, 0.2. And the resistance is 20. So 0.2 times 20, which is 4 volts. So a mark for that. That's part 1. Part 2, it would like us to calculate the potential difference across R. Well, if we've got 6 volts here and this one's taking 4 volts, the voltage across R is going to be 6, which is our total, minus 4, which is 2 volts. So a tick for that if you got that right. And number 3, the resistance of R. So we're going to use V equals IR again. Resistance of R is going to be its potential difference divided by the current. The potential difference we just calculated is 2, and the current is the same all the way around the circuit because it's a series circuit, so it's 0.2. 2. So 2 divided by 0.2, which is 10 ohms. You can tell it's 10 anyway because the first one gets twice as much voltage, so it must be twice as resistant than the second one, because the ratio. Okay, so that one is out of 4. And then we've got number 4. In number 3, an unknown resistor is placed with a torch bulb. Okay, so we're going to have the same circuit. But with a torch bulb here. Okay, and it tells us that the ammeter now reads a different current. It reads 0.12 amps, so it's a smaller current, so the resistance of the bulb must be higher. Sorry, you couldn't see that. Smaller current, resistance of the bulb must be higher. So we're going to calculate the potential difference across the torch bulb. Now, we don't know we can't figure that out. We don't know enough about it. So we're going to figure out some stuff for this and then figure out that. We want its potential difference. So we can figure out the potential difference that this has. We can take it away from 6. So the first thing we're going to do is figure out the potential difference of the 20 ohm resistor, which is IR. So we're going to do 0.12 times 20, which is 2.4 volts. 1 mark for doing that. So then we can do the voltage of the bulb is going to be the total, which is 6 minus 2.4, okay, which is 3.6 volts. So tick for that one. And then it wants us to calculate the resistance of the torch bulb. So resistance is voltage divided by current from Ohm's law, V equals IR. So its voltage of the bulb is 3.6 and its current is 0.12 because the current's the same all the way around. So that is 30 ohms for 1 mark. So that one's out of 3. So the total for the whole thing is 7, 8, 9, 10, 14. So if you can comment your percentage that you got right for those, that would be great. It's out of 14. If you've got any questions, let me know. Thank you.